All right, let's start with number 4 on page 377. So it's about auto insurance claims. And what's gone on is we've looked at 370 claims and found that the average that the company has to pay is $1,570. But the whole point of this problem and um, pretty much the entire chapter was we want to guess the average of the whole population, or in this case, that would be every claim that's filed um, to that company. So we have a starting point. Based off our sample, we would guess, the average for every claim is around 1,570. But, it's not going to exactly be that. Our sample is not going to be perfect. Um, so we're going to try to guess the interval where, the real average is somewhere within this interval. And if we want to be really, really confident, we would guess a big interval. The larger you make the interval to a small number here to a number that's even bigger than 1570 here, you could be really confident, like 99% confident, that the real average is somewhere between those two numbers. And if you want to be a little less confident, that'd be like a 90% interval. You'd have 90% confidence if you selected a smaller interval of numbers. So the way we actually figure out how large these intervals are going to be based on our confidence is we have to use some statistical formulas here. And notice that they told us what sigma was, or the standard deviation. And they said it's 250. So if we know what sigma is, if we know the standard deviation, we're dealing with 8.1. We're going to estimate the mean when we know what the standard deviation is. And if you look at page 342, that's going to be where the steps are to help you figure out, how big an interval do you need to get a good estimation of what the mean is. So before we look at page 342, notice, the mean's right in the middle. Our sample mean here is 1570. And for our guess of, where the actual mean lies, we're going to, take that number and add some error. This is called the error of estimation, because we think 1570 probably has some error. It's not exactly right because we just took a sample. So we're going to add a little bit to get a larger number, and we're going to subtract a little bit to get a smaller number. And then somewhere within that range is where we're going to say the real mean is somewhere within that range. So, like I mentioned, E is going to be different for a 99% confidence interval because you're going to need to add more to be 99% confident. You have to have a pretty big interval. And then E is going to be a little smaller for like a 90% confidence, because you can use a smaller interval if you're only 90% confident. All right, so if we're using the formula on page 342, it's in that gray box. So remember, what we're trying to do is to find the real mean. What's the real average for the claim paid? And it's going to be, what we're going to use for our guess is our average for our sample minus some number, and our average from our sample plus some number, and say, the real mean is somewhere in between there. And to figure out what we minus and what we're plussing, we use that formula on page 342. And I'm going to do the example for 80% confidence. And then for the problem, you're actually going to do 90% and 99%. I believe that's what it says. So a lot of this formula you already know. This was given to you in the problem. They said that the standard deviation was 250. So you would plug a 250 in. This was given to you in the problem. They said they took a sample of 370. So you plug 370 in. This is what you need to use the table in the book to look up. and it's based on the confidence level. So for 80% confidence, you go to the table, which is on page A9 in the appendix, table B3. And for 80% confidence, you use 1.28. So it tells you for each percent confidence what number to use. So you plug that number in, use a calculator, you'll get 16.64 is what E should be. So we're going to do the mean minus that and the mean plus that. So if you do that, our sample mean minus 16.64 and our sample mean plus 16.64, we now have a guess for the real mean. We're going to say the real mean is between those two numbers. And we are 80% confident that it's between there because we used the 80%. So what that means is if we did 100 samples like this 80 times, we'd actually be right, and the mean would be in between what we come up with here. All right, and just to show you one more example, if we did 85% confidence, the only difference would be now we use 1.44 for 85. So you plug 1.44 in there and you get 18.72 if you use a calculator. So again, you're going to do our sample average minus that, or sample average plus that. And now we have a new guess for the mean, and it's the actual mean, the actual average for the amount of money paid per claim is between these two numbers. And now we are 85% confident about that. So we got a little more confident, and you can see kind of why we're more confident, because we made a bigger guess. Instead of saying just between 1553 and 1586, we now go even lower. We say, well, the real mean could be as low as 1551 or as high as 1588. We've included some extra numbers that the real mean could be, so now that increased our confidence of our guess. So do this same thing, but you're going to do it, the problem asks for 90% confidence, and let me make sure I'm telling you right. Yeah, 90% and 99% confidence. So use that table in the book to look up, well, here's 90%. You're going to use 1.645 for the 90%. And then use that table to figure out what number to use for 99%. So for number 6 now, on page 377, we kind of change our thinking a little bit. Now we want to set up a situation where we're going to take a sample, and we want to guarantee that our sample mean is close to the real mean by just maybe +2 or -2. So whatever the sample mean is, it's very close to the real mean. It may differ by just +2 or -2. And we want to be 99% confident that that's the case. Remember I talked earlier about, you can make, to be more confident, you could really make, a longer interval with more numbers to guess. That'll increase your confidence. But we don't want to do that. We just want to go +2 or -2. So another way to increase your confidence is to survey more people, or have a larger a larger sample size. The larger your sample size, the closer your sample mean is going to be to the actual mean. Think about it. If you sampled every single person, your sample mean would actually be perfect. It would be the real mean, because you've averaged everybody. But it's not realistic to take a sample of every single person usually. So we're just going to take a sample, but the larger we make it, the closer our guess will be to the real mean, and then we can figure out exactly how many people we need in our sample, so that with 99% confidence, we're only 2 away from the real mean. So to do that, you got to use the formula, again from section 8.1 on page 345. This formula is on page 345. And again, we're using that one because the problem tells us what the standard deviation is. So we can use the formula that has the standard deviation in it. All right, and for what I'm going to show you is 95% confident that the sample mean is within 2 points of the real mean, the population mean. The problem, I believe, wants 99%, so you'll have to make a few adjustments. But the formula there on page 345 says we need to find, z sub c, sigma, our error of estimation, multiply, divide, and then square. Well, again, you look this up in the appendix in the back of the book, and for 95% confidence, z sub c equals 1.96. Just check that out in table B, or in table 3B on page A9. All right, so z sub c equals 1.96. Sigma was given to us in the problem, 7.81, and our error of estimation was also given to us. We want to be within 2 points either way. So you plug all those in. And then you do the multiplication, division, make sure you do all that first, get a number, then square it, and you get 58.58. So what that means is, if we ask 58.58 people, or include that many people in our survey, we will be 95% confident that whatever the average is from those 58.58 people, whatever the average is, it's only 2 away. We're within 2 points. Of course, you can't do 58.58 people. You can't get a half a person. So we need to sample 59 people.